Hello, this is the Best Mac Tutorials, back with another Java tutorial. I know it's been a while since I last did one, and I intend on doing a couple more in the near future. And so, let's get started. This Java tutorial is going to be essentially showing you how to do Java input-output. That means like writing numbers or whatever to a file. The program I'm going to be making today is going to basically generate a user input amount of numbers, make a file out of it, or multiple files, and then depending on user input, either include or not include a total sum and an average of all those numbers. And so we're going to import java.io.wildcard and import java.util.wildcard. We're importing java.io for input alpha for the file writer, etc., and java.util for the random class and the scanner class. And so I'm just going to start right away. I'm going to make a double that I'm going to call total sum. I'm going to set that equal to 0. I'm going to make my scanner object. So scanner in equals new scanner system.in. And then we are going to prompt the user for the amount of numbers they want in the file. So that'll be system.now.println how many numbers would you like in the text file. And then we're going to say that a double, say just a equals in.next double. And then we're going to set a double of b equal to a, and you'll see why in just a minute. It's when we're doing multiple files. So it'll allow us to set a back equal to what it was earlier, so that the consecutive files after the first file aren't completely blank. So b equals a, then we're going to do a systemout.println. We're going to prompt the user for how many files they would like. So how many files would you like us to create? And we're just going to have a double, or actually we'll do an integer here. So an integer, let's say g1 equals in.next int. And then we're going to add one to g1. System.out.println. Would you like the average of all the numbers and the sum of all the numbers added to the end of the file? We're going to say systemout.println 1 yes, and systemout.println 2 no. So now we're going to have, actually, I'm going to do this in reverse. I'm going to do 0 here, and that'll be no. And a 1 here, and that'll be yes. And so then we're going to say a double, just arbitrary q, equals in.next double. And I'm using a double so that people can't intentionally screw with this system very easily by typing in something like 500 nines or 300 nines or whatever. So then we'll create our random object, random equals new random, and then we will start our file creation thing. So while g1 is greater than 1, we're going to subtract 1 from g1 like that. We're going to create a string, and that string is going to be called g, and that's going to be integer.toString g1. And the magic of this is, so say they type in it creates this integer.toString is going to be extremely useful later when we're doing our file writer, actually on the next line, when we're creating the file, because then we can name it the number that it's currently on. And so, just like this, file writer out file equals new file writer, and let's see. The way I like to do this, especially if I don't know how exactly or where exactly I navigate to the folder where I want the file. I open text edit document like this, go format, make plain text. Then I drag this file in and delete the actual file part of it. And I say, okay, so that's the path. That's where, in my documents folder, for example, that's where I want all these numbers to be, all these files to be randomly thrown. Remember this backslash here. That's very important, or else it'll create a folder called, or a file called documents plus the number, so, you know, documents49.txt in the folder tutorials. And then we're going to go outside of these quotes, and we're going to put plus g plus .txt. And it does not like that. Oh, we have to do our try catch. So we're going to try this, and we are going to, okay, so I'm going to indent all this to make it easier to read. We have to do our try catch for file ready to work. It's a protection against input-output errors, such as, you know, no permission for that area or whatever. See, and this is the problem with indenting stuff. Eventually, you get stuff that's, oops, I don't need to put it out that far. You get stuff that's way off, like it's, you know, way over here, and so I kind of try to be a little careful with how much indenting I do. Sometimes if it's a really small little thing of brackets, I will kind of think, well, do I really need to indent? So, you know, and the answer is usually no for really small ones. And so let's see. We're going to need a catch. So we're going to need to down here say catch IO exception E, and then say that if in fact you do, then e.print stack trace. And so that's basically throwing the error at the user, screaming, "Hey, idiot!" That's what this catch does. And so you need this in order to be able to use FileWriter, OutFile, etc. Just because, for safety reasons, you don't severely screw up your file system, and so that's why you do. That's why the try and catch is actually required by the compiler in this case. At least I would imagine so. And so now in here we can put print writer out equals new print writer out file, like that. And so we're creating, spelled that wrong. And so we're creating a print writer object called out. So now, and we could call that, you know, potato or anything. But this way we can do stuff like out.print the variable b, like that. And so anyway, instead of, you know, potato dot print variable b, you know what I mean? Out makes it a lot more logical and makes it similar to the system.out.println command, which we're already very familiar with. So now I'm going to create two doubles here. I'm going to create a double called counter, and I'm going to set that equal to 0, and a double called total counter and set that equal to 0. I want that capitalized for some reason. And now we're going to make a embedded while or nested while loop. So we're going to say while a is greater than 0. Then we want to do this. And inside of here, we're going to tell it to create a double called j, and it's going to be equal to random.next int. And I'm going to say 200,000. That way it doesn't go into exponential notation, such as, you know, 1.39 E11, which means 1.37 E11, which means 1.37 times 10 to the 11th. So double j, and we're going to say that total sum equals total sum plus j. And so the first time this runs, total sum is equal to 0, so so total sum is equal to 0 plus whatever j is, so say, 2000, and then the next time total sum is 2000, so it equals 2000 plus j, and if j is again 2000, then we now have 4000, or if j was 2001, we have 4001, etc. And so that's going to be helpful when we're printing all that information out to the file for the user. And so we're going to say out.print, oops, not println, print j, and so it's going to print every time it runs this, it's going to print j out to the file. And then we're going to do out.print a comma and then a space, so it separates the numbers. And we're going to subtract 1 from a at this point. Now we're going to add 1 to counter, because we've done this one time. And we're going to do an if statement. If counter is equal to, let's say 500,000, then we want it to do this. Indent. See what I'm saying? These indents get kind of far out. It's like you lose all this space to type in, and then you have to scroll over, but it's common convention. Total counter equals total counter plus counter. Then we're going to do systemout.println. We are still working and have generated plus total counter plus numbers. And so this will, as we're running it, every time we generate 500,000 numbers, then it'll say, hey, we're still working, this is our progress. And the reason we don't just print counter is because we're going to reset counter here. And the reason we do that is because then we'd only get one of these, then at 1 million it wouldn't do anything because counter is 1 million and it's not equal to 500,000. And if we did greater than, then we get one every time after 500,000. And so we have to set counter to 0, and then there's this total counter, which is then equal to total counter plus counter, so that then we can print out total counter instead of every time it's saying we're still working out of generated 500,000 numbers, we are still working out of generated 500,000 numbers. And so when you're at 10 million, it'll say we are still working out of generated 500,000 numbers. So that's why we have to use these two variables here, at least for now. And so that's the end of that if statement. So it's just going to end here. Then we're going to put a equals b. That way when we do this again, and it does this while a is greater than 0, a doesn't equal 0, so the next file and the file after that and the file after that and the file after that is blank. Instead, we just set a equal to b, which b was set equal to what a was earlier. That's the only real thing we use b for. We could also use it for we have generated the plus b plus space files you wanted, like numbers you wanted into the file. We could always use it like that. But here we're just using it to refresh a so that this can be done again. Instead of this being completely skipped over because a is already equal to 0. And so now we're going to do some if statements for printing that additional information out to the file. So that'll be if q is less than 0. This is the idiot catcher. Then system.out.println. Wow, how did you screw that one up? And then it'll say system.out.println. We have saved your file without the average and sum. And so then if q is greater than 1, and if they enter 0.99, they're purposely trying to mess with the system, so I'm not even worrying about checking that. I'm just doing this to get rid of integers. So if they accidentally type 2, or they accidentally hit the 2 key instead of the 1 or something, system.out.println, wow, how did you screw that one up? And then system.out.println, we have saved your file without the average and sum. And then, if q is actually by some chance equal to 0, then system.out.println, we have not saved the average and sum to the file. And then, if q by some chance is equal to 1, system.out.println, we have saved the average and sum to the file. And then under that, I mean, it's actually technically a lie at that point because you save it right after that runs, but it's in the same second, so it doesn't really matter. And so here we will put our out.println empty to add a space and enter in between the numbers and this, then out.println bunch of these hyphens to kind of give a nice separator. That should be good. An extra 4 just because I feel like it. Oh, and we have to put these in quotes, of course, because in fact this is a string. There we go. And then we're going to do another out.println the sum of all the random numbers is plus total sum, and then out.println the sum of all the random numbers, or the average, and this is actually of all the random numbers is, and this actually we could use b here, and in fact I think I will. Total sum divided by b. That way we just divide the total by the amount of numbers that were generated, which gives us the average of all those numbers generated. And so if we wanted this to not be a lie, we could in fact put that right here, like that. Always save while you're working. Now, outside of these brackets here, before the catch, but outside here, we're going to put system.out.println the task has completed, and counter is set equal to 0. Total counter is set equal to 0, and we'll set total sum back equal to 0. And then we'll do out.close. We're closing our output to that file. And so really, did we need, I mean, total sum is the only one that's declared out here. Counter and total counter are declared within this, so they would be cleared anyway. Do we really need to clear them? No, we don't really need to. It's just an extra security. It takes practically no extra clock time to do. And, you know, it illustrates the point of what's going on, that these are cleared. I could, in fact, delete these two, although, you know, like that, it really wouldn't matter. So let's run this and see if it works. Should, because there's no warnings. How many numbers would you like in the file? Say 20. How many files would you like us to create? Say 5. Would you like the average of all the numbers and the sum of all the numbers added to the end of the file? 1. Yes. So you see, every time it does it, it prints out the task is completed, and we have saved the average and sum to the file, or have not. Or if you screw up, then every time it'll give you that, how did you screw that one up? And you see here in documents, 1.text, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. 20 numbers. And then it has this information printed out to it. You'll see it has the average here and the sum here. So 5, 4, 3, 2, 1, they all have it. The reason that's moving this area, it's here on this file and here on that file, is just because some of the numbers are different lengths. As you can see, based on this average, this one was really far off from the average, and the more numbers we generate, of course, the better results we'll have. So let's test out, you know, say 2 million, and we'll create 5 files, and we'll say no, we don't want that. Actually, yes, we do want that information. Wait. Okay, so we would want 2 million. How many files? We'd like 5, and yes, we would like that information included. And so now it's still working on those, but I'll pull up Finder. Okay, so as you see in 5.txt, it is now a pretty big file for text, 18.9 megabytes. You know, you could add another 0 and it'd be 189 megabytes-ish, you know, and so you can create large files very quickly with this type of program. As you see all the way down at the end, that's a more dead-on average. I mean, it's only 51 off. It should be approximately 100,000 because we're doing everything in a range of 0 to 1,000 to 199,999 for the numbers that we're generating. So this, in fact, should be theoretically practically dead on. It should be, you know, just the tiniest little bit off from 100,000 ideally. But of course, you know, it's a random number generator, so you're going to get different results. And so if I go to another one, they take forever to load because it's, 18 megabytes of text, which is kind of things not used to really opening. You see this one was a little on the low side, but anyway. So that is the program. I will put the source code for this in a Mediafire download. I will put that link in the description. Please comment below or message me on YouTube if you have any questions about this tutorial or any other tutorials that I've done. I am hoping to do another tutorial soon, maybe on, I don't know what I'll do it on, but I hope to do another one pretty soon. And that's about it. Bye. Hello, this is eBest Mac Tutorials, back with another Java tutorial. This time it's Java Tutorial 13. Please watch this video in HD full screen in order to read the text on the screen better. Today I'll be, and this is going to be a very long tutorial as you can tell from the time remaining until the end. When you're watching this video it's probably going to be like an hour and a half, but at the least.